right, good morning, folks. This is Mike coming back at you with another video on Intro to Algebra. In the previous video, we wrapped up Chapter 3, and we talked about the two main forms in which we can write the equation for a line, point-slope form and slope-intercept form. In this video, we're going to start Chapter 4, and we're going to begin talking about the product rule and power rules for exponents. And we're going to revisit the concept of exponential expressions, something that we talked about all the way back at the very, very beginning of this course, back in section 1.1. So we've talked about exponential expressions before. Basically, we've said what they were, but now let's do some operations with these things. Specifically, what happens if we try to multiply exponential expressions where the bases are the same? So we know that every exponential expression has two pieces to it. Here's an example of an exponential expression. 7 raised to the power of 4, or 7 raised to the 4th power. The number that's down on the bottom, if you will, just as a quick recap, is the base, and the number that's in the upper right-hand corner is the exponent. So what happens when we multiply things like this and the bases are the same? So here is a sample. What is 3 to the 4th times 3 to the 2nd, or 3 squared? Okay, well, let's just recall what each of these things is actually saying. 3 to the power of 4 is saying 3 times 3 times 3 times 3. So there's your 3 to the power of 4. And then times 3 to the power of 2, or 3 squared, is just 3 times 3. So all we've done is we've just rewritten what we had. But instead of looking at this as a piece times a piece, now let's look at the whole thing. Really what I'm doing overall here is I'm multiplying 3 by itself 6 times. 3 times 3 times 3 times 3 times 3 times 3. So again, using that same definition of what an exponential expression is, this is the same thing as 3 to the power of 6. Now, comparing what we had, what we were given, to what we found that it was the same, we see that when I multiplied these two exponential expressions where the bases were the same, we kept the same base, but the power here is simply the sum of these two powers. That result is generally true. That holds no matter what base and no matter what exponent you have. If you have real numbers a, b, and c, then a to the power of b times a to the power of c is equal to a raised to the power b plus c. So when you're multiplying exponential expressions where the bases are the same, and I stress that the bases have to be the same, then you take the same base and you just add those powers. And that is what you have. Now, this works with more than just two exponential expressions here that you're going to multiply. If you have a to the b times a to the c times a to the d And you could multiply this by any number of exponential expressions where the base is a for all of them. This is equal to a to the b plus c plus d plus dot, dot, dot. So it doesn't matter how many exponential expressions you multiply, as long as the bases are the same, you just add those powers. And the bases don't even have to be numbers. They can, and often are, something that contains a variable. So we're going to consolidate each of these products. We're going to use this rule here to see how we can rewrite each of these things. I have 7 to the 4th times 7 to the 5th. Well, recall, 7 is the same thing as saying 7 to the power of 1. Because anything you raise to the first power is just that same thing. So here I see I have bases that are all the same. So that's good. That means that when I multiply these things, I'm going to get something that has the same base, but now I add these powers. So it's 4 plus 1 plus 5, which gives me 10. And you could plug this number into your calculator. You do get a very large number. I believe it's over 282 million, but you do get a large number here. Let's go to the next one here. 5 times x squared times negative 2 times x raised to the 4th power. This is something we're going to be doing a lot of later on in this chapter, in the rest of this course, and then in subsequent math courses. So how do you multiply things where you have a variable as your base, and then you have numbers in front of that exponential expression that you have? So when you do this, you multiply the numbers in front of your exponential expressions first. You multiply those coefficients. So these are my coefficients. So it's going to be 5 times a negative 2, and then you are going to take the product of your exponential expressions. X squared times x to the 4th. So multiply the coefficients, multiply the exponential expressions. So 5 times negative 2 is going to be negative 10. And then x squared times x to the 4th. Again, the bases are the same. So we're going to keep the same base, and then our new exponent is going to be the sum of these two. So 2 plus 4 is 6. This one I'll let you try on your own. I think you'll be able to figure that out now. This one here, 5 squared times 2 raised to the 5th power. Look at this carefully. The bases are not the same. The bases are not the same. When the bases are not the same, we cannot use this property. We just have to figure out what are each of these things separately and then multiply them out. So 5 squared, or 5 times 5, is 25, times 2 raised to the power of 5. You can verify in your calculator that that is 32. And then if you do 25 times 32, you'll find that you get 800. So this is the first of our properties of exponents. These things are commonly referred to as. When the bases are the same and you're multiplying exponential expressions where the bases are the same, you keep the base, you add the powers. Okay, so that was multiplying exponential expressions where the bases are the same, but the powers aren't necessarily the same. What if we multiply an exponential expression by itself? What if we multiply an exponential expression by that same thing? For example, what is 2 cubed, or 2 to the third power, that thing raised to the third power? Well, this is a little bit odd, but if we just think of the definition of the exponent, what this says here is I'm going to take this thing right here, and I'm going to multiply it by itself 3 times. So that's going to give me 2 to the third, 2 to the third, times 2 to the third. That's just the definition of what this is saying right here. It's saying take this thing here and multiply it by itself that many times. Okay, well, now this is just like what we just did. We have the product of 3 exponential expressions. The bases are all the same. So we keep the base and we add those exponents. 3 plus 3 plus 3 is 9. Well, if we compare these two quantities here, which we know are the same, it looks like we just multiplied these powers to get our new power, because 3 times 3 is 9. And that is indeed the general case. That is indeed generally true. If A, B, and C are all real numbers, again, A can certainly be a variable, then A to the power of B, and then take that whole quantity and raise it to the power of C, is equal to A raised to the power B times C. So in this case, when you have an exponential expression then being raised to some power, you are going to keep the base the same, but you're going to multiply the exponents. You're not going to add them. So as a couple samples here, 5 squared, and then that then raised to the 5th power. We see that this is an exponential expression then being raised to some other power. So we are going to use this property right here, and this is going to equal 5, because that was our base, and the base remains the same. And it's going to be 2 times 5 here. So 5, and we all know 2 times 5 is 10. So 5 raised to the 10th power. Again, you could plug this number into your calculator and you would get an actual value. It's going to be another large value, but you could find it. And then the second one, x to the 10th power, and that thing squared, or raised to the power of 2. So it's going to be just the same kind of thing. The base remains the same, and then the exponents get multiplied, and 10 times 2 is equal to 20. Again, very important to keep in mind the difference between this property and the property that we stated previously. The previously stated property was that right there. And then the property that we just went through here. A raised to the power B times C. These aren't the same thing. They may look like they're saying the same thing, and people still get tripped up over it. However, this is not the same thing, so you do have to be careful here. All right, guys, that concludes this video on the product rule, if you will, and power rules for exponents. We will continue with this section and continue with this topic in the next video. If you have questions or comments, be sure to reach out to me, guys. Emails, texts, phone calls, in-person visits, telegrams, SOS flares, whatever you need to do. Otherwise, until the next video, take it easy, guys.